Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is surrounded regions. Let's go to LeetCode and give this problem a read. So you are given an M cross N matrix called board containing letters X and O's. Now we have to capture regions that are surrounded. So basically these 3 pointers, I'm going to just summarize it like rather than reading it out. So here is our board filled with X's and O's. We need to capture the regions that are filled with O's, and the entire region is basically surrounded four directionally except the diagonals, so four directionally by X's. What does that mean? So right here, as you can see, this particular board, this particular region has been captured by X's because it was four directionally connected by X's. This one was not because it doesn't have an X below this cell's address. Okay, so we understand the problem. After we capture all the regions, then we return the entire, basically this board. So let's understand how we actually going to do it. So as you can see right here, that over here, this particular region was captured, and the only reason this was captured is because if you connect the entire region right here, so this is connected, this cell is connected right here. These are the borders of this particular region. And of course we are not considering the diagonals. Okay, and as you can see, this right here has been captured, and if you can see, it has been filled in our answer with the X's. That's it. Well, this right here has not been captured. It's right there, it's present in our answer, and the reason is because it does not have an X, so this is not present. It's the border cell and it does not have an X surrounding it. So what's really happening is, if you think about it, this problem, there might be like two ways of solving it. First, you basically find out all the regions of O's. Let's say you are basically traversing through your grid, then you come across an X, then either this particular cell, so for this entire region to be captured, either all the values in this axis have to have O on one of the sides or two of the sides or all the sides if it's some middle cell, and then it has to, whatever appropriate, it has to be right in the middle or somewhere, like it cannot be the border cell. That's because if it's the border cell, then it's like the side that is basically the border, it cannot be surrounded by X's because there will be no value present. So right, so that's one of the way of checking it. And I think it's super complicated. There is like much easier solution. Everyone like does that and talk about like how crazy solution they've just found, but it's like super simple. And I think like while I was going through this problem, I actually like I thought about it. I haven't solved this problem earlier, but like when I was reading it like again and again, and I think while I was thinking that how I should be basically approaching it, like it just came to my mind, how about instead of trying to find these regions like of O's and then trying to see like if they can be captured, what about, I know for sure that all the O's regions present on the border, they cannot be captured. All O's on border, so you can say on border cannot be captured. Well, this is the solution right here. Trust me. Why? So if any of the O's on borders, they cannot be captured, that means if they have any other O's connected to them, so basically the region, there might be other O's that are connected to them, they can also not be captured, because we know for sure that any O on the border will always have one side that is not surrounded by X. So that's why it cannot be captured. That is why any O, let's say if this was the O right here, let's say if this was an O right here, so this will be basically part of all the O's. Okay, let me just convert it like this, and then we can just write, oh my god. Okay, I'm just gonna say, let's say if this was also an O, then you see that this whole region cannot be captured because all other cells are, yes, they are connected, basically they are surrounded by x's, but if you see right here, this particular cell is also part of this whole region, but it does not have an x here. So that is why this whole region cannot be captured if that were the case. So what we're going to do is we will create a queue. We will solve this problem using basically breadth first search. What we will be doing is we'll create a queue. In this queue we will be appending all the O's. We will be visiting all the borders. So right here. So if you see over here 0 1 2 3 0 1 2 3, if you see that this is the O that's present on the border, the address is 3, 1. That is the only O present on the border. We will be putting that into my queue. Then I will run a BFS on this queue to basically find out if there are other O's connected to these O's that are present on the border. So what it will do is, like, it's gonna go, this BFS will go through all the cells, neighboring cells. Of course, they have to be 4 directionally, and especially checking like we're not going out of bounds. And if we find those O's, then we will be putting those into my visit set and also appending that to my queue. So I will maintain a visit set, and in that visit set, what I'll be doing, I will be putting all the values or all the cell values into basically my visit set. Once I'm done visiting, so let's say in this case it's just 1, but let's say if there was another cell present right here, let's say right here this was an O, then I will be appending one more value 0, 1 into my queue. Then once I will be done visiting 3, 1, so this has already been appended. Then I will be exploring this cell I'll be visiting as part of BFS, this cell, and when I visit that, I will check all its neighbors. So there will be one neighbor that has the value O, so I will append that to my basically queue, so 2, 1, 1, and then that will also be part of my visit set. So this has been visited, and we know for sure that we cannot capture it. And in the end, let's say we will be done visiting, you can just simply tell that we will not be able to capture any of these. So we'll add all of them to my visit set, and finally what I'll do, I'll go through this entire board, and any address right here, if any of the cell address that is present in my visit set, then I will basically keep that as O, rest everything I will fill it with X. So that is another way of doing this problem. So let's dive into the code. I don't think like there is super complicated about anything super complicated about this problem, so we will directly jump into the solution. Okay, so I have not written the code for it yet, but we can just dive into it now. Okay, it's saying do not return anything, modify the board in place. Okay, that's it. So let's go over rows and columns. That's what we do. Visit set. Okay, what's the rows? Board. That's the number of rows. What's the number of columns? Length. Board at 0. And then what's the visit set? It's just a set. The reason I'm having all of them in just one line, so that because a lot of the code in graph problems is just quite lengthy, but we want to just fit in so that it's nicely visible on the screen. So what do we do now? We're gonna go over all the borders. So for, let's say, R in range, all the rows, this should be gap. Okay, so what do I do now? Basically I'm gonna check for the value X, and these are string values. So I will check. I can because I'm visiting all the rows, so I'm basically coming from top to bottom, so I can do this side, left side and right side at the same time. So what I'll do is if I would say board at basically R and 0, if it's equals to O, if this is equals to O, then what I can do is I will append that to my queue. I forgot to make the queue. Queue is right here. This is it. Simply, yeah. Just you can also have DQ, but I just like to have simple array. But I think DQ is better because there will not be any shifting in DQ if you're using DQ. Okay, it's inbuilt Python Q. So what do we do? So Q dot append. We are going to append this particular this address of this cell. But what will be the address? R comma 0. No, 0. Okay, that's one thing. There is one more. There is one more. Control C. If this R will remain same, but column -1, that is like going to the right side now. Then also appending same, but C -1. Okay, this is one thing. Then there is one more thing that we can do. We are now gonna basically go through the border cells of top and bottom. So we did left and right. Now we're gonna do basically top and bottom. So we'll have, let's say, call it column in basically C. If R is this time gonna be 0, this R will be 0. This will be small c. This will be small c. We're gonna again check. So 0 and then C and then 0 and then basically C. So not 0, it's gonna be R -1. Okay. All right, so it took us basically 2 for loops to go through and add everything to our now I'm thinking, what if we could have done it using just like two nested for loops, but it'll be the same thing. Doesn't matter, you know. We can combine them to basically in 2 nested loop, and then this is what I'm thinking. Like if I had written the code earlier, I would just nest them together and then only check for the border cells. Okay, it will make the code cleaner. Wouldn't change anything else, right? It would even only make the time complexity worse because then you have nested for loops. Well, anyway, this is complexity wise, this is better. Okay, now what do we do? We have this queue, we have this visit set. Now I'm going to start my while loop. It's a DFS. I'm going to start this while loop. While queue. Let's start exploring. These all the cells that on the border that have the value O that we just added to our queue. So I will basically first thing, let's pull it out. What it's gonna be? It's gonna be R comma C and Q dot pop left. That is basically popping the value from the queue. Then if first thing first, this will what I want to do is I want to add this to my visit set. So visit dot add, and I have declared it visit set. It's better if we have just is at visit. So visit set will be added to, well, we are adding this R and C to our visit set. Now, because we have just popped it, we have added it to my visit set. Now what I want to do is I will go through all its neighbors and try to see all the connected O's to it that are basically adjacent to this particular O, so that I can capture, basically collect all those O's and make this a region and add it to my visit set, because these will be the O's that cannot be captured. All right, so what we'll do for dr dc in basically I'm going to add that. So 1 comma 0, we have been doing this for very long, so you know what we are doing. -1 0, then 0 1, so column plus minus -1, sorry, 0 and -1. Okay, awesome. Now new R, new row, new column, that will be dr plus R, dc plus c. Those are my the address of these border, like not neighboring cells. If they are basically inbound, I mean these two are in range, basically that's what I'm trying to say. It could be out of bound, so we have to check for the valid ones. So if new R is greater than equals to 0, and new column is greater than equals to basically a column, so sorry, 0, and then this new r is less than r, and this new column is less than c, and what, this is not present in my visited set already, and this new r comma new c not in visit, and it's not x, right? So basically board new r and new c is not equals to basically x. Then what we can do, we can add it to my queue. So queue dot append new r comma new c. All right, there might be a little bit typos like this. Well, we'll just take care of them in the end. Okay, so now we are done appending that to my queue, and that will be processed later, and then that will also try to basically explore its neighbors. Okay, also instead of this, I think better would be that you check for the true, don't check for the false, check for the basically truth, you know, rather than checking, because we really want to see that board has O, you know, and it's not in visit set, rather than checking it's not equals to O. Well, that was also correct, but this is better, right? Okay, so this is it. This is the entire code of like you know, BFS. Now what do we do? Finally, we have this set. So we are going to, for r in range, this is where you change the values. This is where you capture this is where you capture all the reasons that are not in my visit set, and convert them to basically change those in place value to x's. So for c in range column. All right, so if this r comma c in my visit set, then board at r comma c is equals to o, else it will be equal to x's, right? Will be equal to x's. So these are the O's that we are actually converting, which could actually be captured. Okay, and finally, we don't have to return anything. They said like we don't have to return anything. The return should be none. Okay, so we're gonna go over this again. This time, like, let's just check for any typos. So we have a row, column, and visit set. Then we have our queue. Then we are basically visiting all the border cells. So just going left and right. So r remains basically that variable that changing in the range r, and then column is what initially is, left is 0, right is c minus 1, and then if they are o, if that value of that cell is equal to o, then I'm appending that to my queue. All right, now and then basically I'm doing the same thing with this time with columns. Okay, so top and bottom. Okay, this also looks good. Then I start my BFS. Basically I pop from the queue. Initially it will be the bordering cells, then I add them to my visit set. Then I explore their neighbors of these particular cells that have the value O. So I'm going basically four directionally, and then finally I have this check if they are you know, in range and the value is not already visited, it's not in visit, and then board at new r new c is equals to O, then I want to basically add it to my visit so that it cannot be captured. So I'm not adding it to my visit here, I'm basically appending it to my queue, so that later when I'll be popping it from you know, the queue, I will be adding it to my visit set. So that is it. And then finally using two for loops, nested for loops, we are visiting basically all the cells and checking if that particular address, that cell address, is present in my visit. Then I am basically keeping it O, because it was O at one point, right? I mean, it would be O that time either. So maybe I could say maybe instead of this I can optimize it, because that will be O already. So if this not in visit set, see, we just saw a little bit of optimization right here. Okay, if this is not in visit set, then it's gonna be X, otherwise they can be O's. Okay, let's run it. I'm gonna zoom out and see if we have any this is not in not that's stupid. Okay, so that was our one mistake. And also right here this is gonna be basically r minus 1. Okay, this is gonna be r minus 1 because that's what we are adding here and that's what we should be checking. And I think everything else seems correct. Let's run it again, and this time yes, let's submit. Hopefully this is a good solution. Yes, it is. Let's okay, so that you can see the solution once again right here. Yes, you can. If anything is hiding, you can see it nicely now. Okay, let's write down the time complexity and space complexity. So time complexity is basically big of n cross m worst case, because we are doing a BFS. At the end we will be visiting all the cells of our board, and max cell present in our board is m cross n because we have this visit set. Okay, and then space complexity is also going to be big of n cross m, and that is because this visit set at the end, maybe there are no access, everything is O, so we'll have to store everything in the board. And that's it. This is a nice solution, and of course this thing you can just combine into a nested for loop. Doesn't matter, I don't think it's gonna harm, but this is also good. Let's go to AlgoYogi, mark this problem solved. See you guys later in the next problem.